see this on the slides, so it will be just a reminder for you. Okay, so this is the formulation of our problem, and this is done in a nice way here. As you can see, the last, one thing I forgot to tell you, the last constraint, x1 and x2 greater or equal to 0. When we have drawn this graph, we have worked in the first quadrant, which means that x1 and x2 both were positive. We will not work in this quadrant or this quadrant or this quadrant. We will work only in the first quadrant, because x1 and x2 both will be positive. So this constraint is there, x1 and x2 greater or equal to 0. And here it is trying to explain the constraints, violation of constraints, and within the constraint, here it's showing that the constraint is violated. If we have x1 is equal to 10 balls and x2 is equal to 30 marks, the constraint is violated. Okay. Graphical solution is limited to only 2 decision variables. If there are more, we will not be able to draw them. So this is the first constraint, second constraint, and this is the area which is common to both constraints. It's called feasible region. Feasible region means that the solution is feasible within that region. We have infinite number of solutions, in fact, but the optimal lies at one of the corner point. This is a isoprofit line here. All right, and this is drawn, and parallel lines are drawn, and it is isoprofit line here that is going through this optimal point. Corner points, we have 4 corners, or rather the book has used only 3 corners. 0, 0 corner is obviously not the solution. So this is 4 corners are there, but 3 are of course possible. He is there, the solution may be there. And we work out the profit at each corner point, and of course this is the maximum we are getting. Now, if you want to visualize the isoprofit line, you see over here, we have changed this parameter here from, I think it was 40 to 70 now, okay, and this is also changed here, 20. Now, when these parameters are changed, you can see the slope of the isoprofit line has been changed, and if you draw parallel lines again and move away from the origin, the last point hit is not B now, it is now C. So the solution, the optimal solution is now at point C, not at point B. So this means that by changing these parameters of objective function, we will have the slope of the objective function will change, and it can change the corner point from one point to another corner point. Okay. Slack variables. This concept of slack variable is when we have this constraint less or equal to, when we make it to equality, we add slack variables. Okay. So for example here, x1 plus 2x2, x1 plus 2x2 is less or equal to 40. Now if we want to make it equality, we will add one variable, we call it slack variable, x1 plus 2x2 plus s1 is equal to 40, which means that anything less than this will be equal to s1, alright, to make it equality. That is called slack variable. Slack variable has physical meaning also. Slack means unused resource. Unused resource. Okay, what was this resource? This was labor hours. Now, if for example, x1 is equal to 10, if x1 is equal to 10 and x2 is equal to 5, okay, so 10 plus 10 is equal to 20, right? If x1 is equal to 10, then x1 is equal to 10 plus 2 and x2, let's say, is equal to 5. If we made 10 bowls and 5 mugs, we will be using how much? 20 hours of labor plus S1 is equal to 40. So S1 will be equal to 20. This 20 is unused hours, slack hours. Slack is unused resource. It has a physical meaning, unused resource. Okay? And normally what we do is writing it in a standard format. We add slack variables in the constraints. Okay? It is used in simplex method. To solve simplex method, we add slack variables. Of course, we are not learning about simplex method here, but in simplex method, we add these slacks. A slack variable typically represents an unused resource. A slack variable contributes nothing to the objective function. We also add in the objective function as well these slack variables with 0 coefficient because they don't bring any profit or cost. Here we have added this in the objective function, 40x1 plus 50x2 plus 0s1 plus 0s2. And here we have added S1 here, and here we have added S2 in this one. In fact, we can add S1 plus S2 in this one with 0 here, and here also 0s1 plus S2 here. And these slacks are given over here as well. When this corner point is used, slack 2 is there, unused resource number 2, resource is unused, 60 pounds of clay is not used. When this point is used, S1 is equal to 10 hours are unused. At this corner point, both the slacks are 0, which means that all the resources are fully used up. No slack 0 means all the resources are fully used up, right? Because slack concept is unused resource. Wadah? Okay. Now this is your chance to formulate. Okay, this is Al-Riyami Furniture Company is there, which produces inexpensive tables and chairs. Processes are similar to that in that both requires a certain amount of hours of carpentry work and in the painting and varnishing department. Each table takes 4 hours of carpentry and 2 hours of painting and varnishing. Each chair requires 3 hours of carpentry and 1 hour of painting and varnishing. There are 240 hours of carpentry time available and 100 hours of painting and varnishing available. Okay, and each table yields a profit of Rial 7 and each chair a profit of 5 Rials. Objective is to maximize the profit. Please formulate this problem.